Hi, my name is Ken, and today I'm excited to talk about our work, How Do Data Analysts Respond to AI Assistants? A Wizard of Oz study. To begin, deriving robust conclusions from data analysis is challenging, as many studies have highlighted that even trained analysts can come up with different conclusions when given the same data set and research question. Prior work has attributed this to the flexibility in analysis decisions and the subsequent difficulty in considering these decisions. In other words, planning analysis, that is deciding on decisions amongst a myriad of potentially valid decisions, is difficult. Analysts must synthesize domain knowledge with their data and statistical expertise to come up with the decisions involved in analysis. During analysis, analysts can be aware of certain decisions, such as those that are from prior steps or the next step in their analysis process. However, there can be more decisions that an assistant can present to the analyst that they may not even be aware of, which can help them be more confident in their subsequent findings. Therefore, given the aforementioned challenges associated with analysis planning, analysts could benefit from planning assistance. With recent advancements of large language models, specifically in code execution assistants such as Github Copilot and ChatGPT, LLMs offer an opportunity for AI-based planning assistance. In the context of data analysis, these assistants excel at execution assistance, that is helping you carry out your analysis decisions once it is already made. However, it is unclear what AI-based planning assistance should look like, where the assistant helps you consider and decide on different decisions. What kind of planning suggestion content should assistants strive for? Should it be analyst or assistant initiated? When should assistance occur? Or how does planning assistance impact analyst workflows? Therefore, we ask our central research question: how do data analysts respond to AI-based planning assistance? In this work, we first categorize suggestion content through literature review and analysis of independent analyses done by data analysts focused on the same dataset and research question. Subsequently, informed by our categorization, we conduct a Wizard of Oz study in which we prepared high-quality suggestions. Finally, we synthesize the results of our study and derive a set of design implications for building AI-based planning assistants. And so to begin, we focus on understanding the scope of assistance. What type of specific planning assistance content could an assistant provide? We begin by identifying works that study the data analysis process and present opportunities for assistance. We sought papers that discuss the end-to-end process and challenges suitable for a text-based assistant to address. This led to 15 publications from which we identified broad categories of assistance. These included domain expertise information, additional statistical knowledge, and guidance for statistical modeling. Next, we analyzed 29 independent analyses from a multi-analyst study. In this study setup, independent teams of analysts are asked to answer the same research question with the same dataset. We look for variations in different teams' approaches and how these variations could be reshaped as suggestions for alternative approaches and mental models. This process helped us refine our categorization into a final set of assistance categories. Amongst others, these included helping with domain background, data wrangling, operationalizing constructs, and forming a conceptual model. With categories defined, we then conducted a Wizard of Oz lab study which focused on two research questions. What suggestions do analysts find helpful? And how do suggestions impact analyst workflows? We are motivated to conduct a Wizard of Oz study using a combination of human-prepared and LLM-generated suggestions to not be limited by the existing technology today, but still be grounded by the technology we have. We used the multi-analyst study from our suggestion categorization to generate realistic data for the wizard. This allowed the wizard, which is aided by LLMs, to synthesize suggestions and manipulate the selection, quality, and timing of recommendations. We recruited 13 analysts with data analysis experience in R or Python. Analysts work with Computational Notebook on the same research question as the multi-analyst study. To facilitate our study, we developed a Jupyter Lab extension that allowed the wizard to surface suggestions to the participant as they used the notebook in a familiar manner. In our findings, we found that analysts like planning assistance, but there is nuance. We asked analysts to give a rating for each suggestion, from which we classified into suggestion categories. Overall, analysts had a positive reaction to most suggestions. For example, P2 found the assistant helpful to consider an overall analysis plan, and P9 liked that the assistant indicated certain decisions they might not have focused on. However, consideration of planning assistance is costly for analysts. When engrossed in a particular analysis task, analysts were often resistant to diverting their focus toward distracting suggestions. Meanwhile, analysts often liked the execution assistance that was provided as a help save them time. In addition, there is a need to consider an analyst's background and timing of assistance. Analysts' varied backgrounds, expertise, and comfortability led to different perspectives, sometimes even for the same suggestion. For example, P1, who is a professor in statistics, found a suggestion interpreting the results of a model offered nothing new, whereas other participants very much liked the assistant provided that interpretation. As well, analysts may have different perspectives for suggestions at different points in their analysis. For example, P5 would have preferred suggestions that continued down the path that they were already on, rather than consider new alternatives. Finally, there is a need to strike a balance between execution and planning assistance. Similar to prior work studying the usage of AI programming assistants, we found analysts liked the time-saving advantages of execution assistance. However, purely focusing on execution assistance can lead analysts to misguided directions. Meanwhile, planning assistance can bring about higher quality decisions, but is costly and needs extra considerations. Given these findings, we discussed 7 design implications for AI-based planning assistance. The first set of implications involve aligning the user and assistant. The first implication for alignment suggests assistants should communicate with analysts to align on analysis goals. For example, during introduction, the assistant can describe its objectives for improving analysis quality, highlight the value of planning assistance, and warn against the pitfalls of prioritizing execution assistance only. Next, because we observed that the same suggestion considered helpful by some participants could be found by others to be too elementary, too distracting, too far from their expertise, or too different from their usual analysis or coding practices to be useful, assistants should provide suggestion content suited to the analyst's background. This could be provided through a template form, or as other works have shown, using language models to elicit human preferences via guided questions. From this, we can gather information about their analysis goals, analysis background, such as favorite libraries, or statistical concepts they are familiar with. Likewise, the interface could allow analysts to iteratively expand on suggestion content for more granular levels of detail. Existing work on interfaces for reading papers already enable users of different backgrounds to explore abstracts at different levels of detail to highlight unfamiliar or uncertain terms and concepts. In addition, assistants should match analysts' preferred level of planning assistance abstraction. There are multiple perspectives of what constitutes planning suggestions, ranging from helping with specific hyperparameters of a modeling decision to providing a comprehensive plan with multiple analysis steps. To address this, the assistant can, for example, allow the user to specify the abstraction of assistance they need. There can be an execution mode that focuses on code execution, a think mode for specific planning suggestions, a reflection mode for connecting decisions and highlighting potential missteps, and an exploration mode for higher level planning suggestions. The next set of applications focus on the timing and initiative. As analysts may be unwilling to consider alternatives at certain points in the analysis, assistants should time suggestions based on analysts' openness to considering alternative approaches. Analysts could explicitly communicate their timing preferences to the assistant, or use a remind me later response to raise suggestions. Assistants should also provide multiple ways to request content for different levels of abstraction. For example, as prior work has explored, a hotkey trigger at the line level could indicate a focus on execution assistance using only the current cell. On the other hand, analysts could specify broader suggestions requesting feedback in a side panel and choose the LM context by selecting relevant cells. Finally, we discussed implications centered on engagement and trust. Assistants should mitigate suggestion over lines by promoting engagement and critical thinking. For this, the system could present a visualization mapping the overall decision paths to demonstrate how a given recommendation could influence the overall analysis. Next, the code and natural language rationale were found to be helpful for analysts to understand where assistants were coming from, and so assistants should adopt multiple explanation methods for increased understanding and trust. As other works have explored for verification of AI-assisted analyses, this can be code comments, suggestion rationale, summary visualizations, and the data table. To conclude, we contribute the first user study to understand how analysts respond to AI-based planning assistance, something that is unexplored with existing assistants. Using findings from our study, we develop a set of design implications for building AI-based planning assistants. These implications focus on aligning with analysts on intent, background, and goals, supporting different levels of abstraction through timing and initiative, and increasing the analyst's understanding and engagement with suggestions. Thank you for listening, and please check out our paper to learn more.